Okay, before we look at the volume and surface area of a right circular cone, let's talk about how to draw them and how they relate to right circular cylinders. So, to remember, the way to draw a right circular cylinder is to begin by drawing a circular base. Okay, so you draw your circular base. Let's try to do a better job than that. That's a little bit better. And over here I'm going to draw the right circular cone. And so to get the right circular cone, we're going to use the exact same base, okay? Because I want you to see the similarities here. Now, to finish the right circular cylinder, you would make a copy, an exact copy of this base. You would then put it exactly above the other base, and you would connect it intuitively here. You'd create walls, and now you've got your cylinder. So instead of having another circular base on top of a cone, much like between a prism and a pyramid, you'll have a single point at the top, and in a cone, this is called a vertex. Okay? And it's called a vertex because it's the only vertex here. In a pyramid, it's called the apex because the base already has some vertices. So anyway, now you simply connect this vertex to the sides of your base, your circular base, and now you have a cone. So what's the relationship here between a right circular cylinder and a right circular cone? Well, a right circular cone takes up 1/3 of the space of 1/3 of the space that a cylinder takes up. Okay? It's not obvious why, but a cone takes up 1/3 of the amount of space that a cylinder takes up. Now, how do you calculate the volume of each of these? Well, let's talk about that. If you recall, the volume of a right circular cylinder is the area of the base times the height and of course the base is a circle, so the area of the base is pi r squared. For a circular cone, it's very similar, except it's 1/3 of the area, or 1/3 of the volume here. So it's 1/3 times the volume of the cone or the cylinder. So notice here, so the height of a cylinder is measured right here, and the base is here. Well, over in the cone, the height is measured from your vertex down to the floor, and so the height of the cone here, I built it so that the height of the cone is the same as the height of the cylinder, and the bases are the same, so the area of the bases are the same as well. So you take 1/3 times the volume of the cylinder, which is pi r squared, times the height. Okay? So that's how you calculate the volume of a cone. It's 1/3 of the cylinder volume. Now the surface area of a cone is a bit more complex, so let's take a look at that. So the entire surface area of a cone is the area of the base plus the area of the wall of the cone up here. So you've got your base area plus your lateral surface area, the wall area. Now the base area is simple. The base is a circle, so the base area is pi r squared. Your lateral surface area, however, is a bit more interesting. Without calculus and some other things, it's not easy to see why, but you calculate the lateral surface area by taking pi times the radius times the slant height. Not the height, but the slant height. Height is always perpendicular to your base, so that was from the vertex down to the center of the floor. Slant height is a bit different. Slant height is literally this slant distance here. So that length is the slant height. And sometimes you may have to use the Pythagorean theorem to find it, but this is how you calculate the surface area of a cone.